Alright guys, welcome back to another one. So just like my previous problems, I've gone through every single question in various orders and completing them in many different ways. Okay, so this is all part A to D. So let me show you how I did everything from the beginning. Yeah, so let's go ahead and walk this through. So it says that the triangle XYZ, so this one over here, in figure 4 has lengths 6, 9 and 4 respectively, and an angle alpha bang in the middle. The point W lies on the line, which is here. The circular arc ZW, which is this bit here, is a major arc of the circle. Okay, so this will be quite important. If this is an arc, there's a good implication that X is usually the center. Okay, and it tells us with center X and radius 4. So sometimes we look at this, and it's very easy to forget where the radius is. Remember, the radius is always from the center of the circle to whatever. Yeah, any line from the center of the circle to the edge to the circle itself. So 6 is not a radius. 6 cuts past the circle. Only the first 4 centimeters is the radius, leaving these extra 2 centimeters to make up the rest of the 6. Anyway, let's have a look. So show that to 3 significant figures, alpha equals 2.2 radians. So we're looking at the angle here. And the easiest way to do this is to realize that we need to work with this triangle here and consider either the sine or cosine rule. So let's evaluate. If we're going to use it, so to use the sine rule, you need to work with 2 lengths and 2 angles. Well, we don't even have 1 angle, so sine rule is off the table, meaning we have to use the cosine rule. Now, the cosine rule takes 2 forms. Either the a squared equals b squared plus c squared version, where you're trying to find the length, or in this case, because we're finding an angle, we should do the second one because the angle is the subject. Now, as for the letters, because you only have a single angle, this makes alpha the default a. So this part here should be A. Okay, and yeah, we're going to select this one. So since alpha is A, that means that the length opposite capital A must be little a. So that means the length A would be 9, leaving B and C to be either 4 or 6. So B and C doesn't matter. Always remember that you always have to focus where the angle is. If the angle is A, the length opposite is A, and the B and C doesn't really matter. Anyway, it should look a bit like this. So b squared plus c squared minus a squared is 4 squared plus 6 squared minus 9 squared over 2 times 4 times 6. Easy stuff. And then, of course, a is cos alpha. Now, all you want to do literally is firstly make sure your calculator is in radian mode, and then evaluate this, and then cos inverse. And then finally, you get 2.22 radians. Easy stuff. So, let's move on to B now, yeah? Now, it tells us here that we need to find the area in centimeters squared of the major sector. XZWX. In other words, the whole area shaded in right now. So this is the major sector. Now the only problem here is that the angle we calculate here is alpha, and when you work with a sector, you need to find the actual angle that's required. So we need to find angle inside. Now recall that the angle around a point must add up to 360 degrees, or in this case 2 pi, because 2 pi is 360. So if you know alpha, this must be alpha short of 2 pi, so 2 pi minus alpha. So that's what I call it, 2 pi minus alpha. And the area of the sectors is usually half r squared theta. So r is the radius, theta is just the angle you're working with. So in our case, this big angle we're working with is 2 pi minus alpha. So that's it, just plug it all in. So plug in the radius of 4, because we know the radius is 4, and the angle is 2 pi minus 2.22. I wouldn't bother evaluating it early. I would just put it all in the calculator once, just to get your answer. And doing so, you should get about 32.5. Easy. So, let's move on to the next bit now, you guys. So, what's the next one? 10. Area of the logo. So the region shown shaded in figure 4 is to be used as a design for the logo. Calculate the area of the logo. So the area of the logo, in other words, means it's a combination of the area of the triangle and also the area of the major sector. So in other words, that is what we're trying to work out, the sum of them. Now, first things first, let's look at the area of triangle for a bit. When it comes to the area of triangle, always use a generic formula, which is half AB sine C. Okay, visually that looks like this. So you need to find an angle. You need to make sure you have an angle between 2 known lengths. So if we just match this triangle to this triangle here, we can see that A is 4, B is 6, and angle C is alpha. And then you just plug it in. So since you know all of this information, pop it in, and you're going to have half times 4 times 6 sine 2.22. Now I will just leave this for a second, because since you're going to add up the final answers, it's best you do this calculation all at once to get a clear, perfect, unrounded answer. Yeah. Now let's move on to the area sector. Well, as for the area sector, we already did it. This is a part B problem. We found that the major sector was about 32.5. So you could use this answer, but for the purpose of accuracy, I'm using the uncalculated answer. So I'm going to put this in my calculator: half times 4 squared, so on. And I'm going to add this to the area triangle version. And doing so will give us the area of the logo at around 42.1. If you use your 32.5, you should get about 42.05 ... which is still 42.1-ish. By the way, always try not to round any answers early. Always do it all at once, okay? That usually guarantees a higher accuracy, and you might lose a mark. So I can't really guarantee that. Anyway, guys, let's look at the final part, D. So this one wants us to find the perimeter of the logo, and to be honest, this is the easiest one, in my opinion. The only thing you may not have, firstly, is the arc length. And just a quick recap: perimeter is the length around the shape. So you're not looking through the dotted lines, okay? Always around the shape. We know firstly that we've got a length here which is 9. We have a short length here which is meant to be 2, because we know that the radius is 4, and 4 plus 2 will give us the whole length 6. And then we also got the arc length, and now the arc length is defined as r theta, radius times the angle that it's reflecting. So the angle of interest would be this 2 pi minus alpha angle. So naturally it looks a bit like that, yeah? So you should write it firstly like this, label it 2, and then replace the arc length with radius 4 times 2 pi minus 2.22. So remember, this was this external angle, yeah? And that's it, guys. Just pop in a calculator and you should get about 27.3, and that's it. Done. Anyway, I hope this video helped, and it's covered every single thing you need to know. But yeah, I just want to say thanks for watching, guys, and if you enjoyed this video, give me a like, share, subscribe if you're subscribe, and oh God, I'm getting so tired. And I shall see you next time. Ciao.